All right, guys, just a short lecture on the seafloor. I'm not going to spend a ton of time on this, and again, I want you to kind of skim through this chapter, and we're going to be jumping into plate tectonics here. So if you have further questions or need clarification, please let me know. Just a few kind of basic reminders from probably we talked about this at the beginning of the year, but just recall that Earth's surface is covered by 70% of oceans, and that those oceans originated primarily from volcanoes and outgassing of water vapor from the Earth's interior. Think back to early Earth history, 4.5 billion years ago, and we definitely did not have oceans. It was molten rock that was starting to cool down, and as things got cool enough, that water vapor condensed and started to form puddles and eventually oceans. So, seafloor rocks are widespread, but obviously difficult to study because they're underwater. It's not as easy as just walking up to an outcrop and checking it out. So there's a lot of different ways that we can study them, from rock dredges, just dragging stuff along the bottom of the ocean, picking up rocks, seafloor drilling if we're at the continental margins and in shallower areas where we can drill down and it's not too deep, and submersibles, going down in submarines and checking things out. We can take photographs, we can bring samples to the surface, etc. We also have indirect observations that we can make using sonar or seismic reflection, so sending sound waves. For both of them, essentially, the seismic are just kind of a lower, stronger sound wave, essentially, and reflecting that off of the bottom to map what's going on at the surface and a little bit underneath the surface of the ocean floor. We have passive continental margins, active, and then mid-ocean ridge systems. Passive is where there isn't a whole lot going on anymore. So think the east coast of the United States. There's a continental shelf, continental slope, the rise, and the abyssal plain. But at an active margin, it's where we have plates subducting underneath other plates. There's stuff going on, and we'll see a deep ocean trench off the shore. So northern United States along at Alaska. We have a trench off of our shore because it was more recently active. And the mid-oceanic ridge system encircles the globe, typically running down the middle of the center of the oceans. And so a perfect example of that would be the mid-ocean ridge out in the Atlantic Ocean. We'll talk a little bit more about seamounts, but we can have we'll wait and talk about those. So continental shelves and slopes. Shelves are very, very gradual, almost flat, gently sloping at about 0.1 degrees. They range in width from a few kilometers to over 500 kilometers and have fairly young sediments, so new stuff. Continental slopes are a lot more steep, and they extend down to the edge of the continental, extend down from the shelf down to the abyssal plain. And we also have submarine canyons. Remember, the ocean is not just this flat, sandy bottom like we might see in SpongeBob or something like that. I haven't watched enough SpongeBob to be certain of that statement, so I'm sorry if I'm incorrect. But it's very mountainous. There's mountains, there's canyons. Think of the topography on the surface of the earth, but underwater. And so we have V-shaped valleys that run across these continental shelves and down the slopes. They deliver sediments to abyssal fans. So just like a regular canyon's gonna have sediment weathered and eroded and end up at the bottom of a canyon, you have that underwater also. Turbidity currents are currents with water that have a lot of sediment in it that flow down these continental slopes and can actually be destructive. They've actually broken cables, telephone cables and things that are underneath the ocean. And so that's what turbidity currents are. Passive continental margins, again, not a whole lot going on there. continental rise is a gentle seaward sloping, excuse me, of about 5 degrees, and these are wedges of sediment that extend from the base of the continental slope to the deep ocean. So if we look at this diagram here, we've got this continental rise going on to the abyssal plain, and they lie on top of the oceanic crust. And then abyssal plains are super flat areas beyond the base of the continental rise, and they're the flattest features on Earth with slopes of less than 0.01 degrees, and they form where sufficient turbidity currents exist to completely bury the rugged topography. So we have those currents that are burying what wasn't flat but is now very flat. And then active continental margin, we see ocean trenches. You can see we have a plate subducting underneath another plate. We're going to have earthquakes there. These ocean trenches are the deepest places in the Earth. They're very, very deep. The Marianas Trench is an example of an oceanic trench. The trench off of Monterey is another example. Let's see, what else do we need to cover here? Volcanoes can be found above part of Banff Zone, arranged in long parallel belts. If we're out in the ocean, if we're on a continental margin, we have volcanoes that form, but we'll talk more about that next chapter. And they're marked by very low heat flow and large negative gravity anomalies. Mid-oceanic ridges. Are we doing on time? Pretty close. We'll probably have to split this in half. Mid-ocean ridges occur, again, out in the middle of the ocean. It's a rift valley that runs down the crest, or there is a rift valley that runs down the crest of the ridge. The geologic activity is at the ridges. We have a lot of young basalt flowing out. This is where new crust is forming. We have shallow focus earthquakes. These aren't going to be deep like we'd find in a subduction zone. We have extremely high heat flow, and it's offset along the transform fracture zones. So I think on my next page I've got a diagram that we'll take a quick look at. There's also a lot of biologic activity that happens along smokers that occur. There's hot springs, and there's unique communities that exist around these because of the high heat and different minerals that are associated with these areas. Also, you'll find lots of mussels, crabs, tube worms, thermophilic bacteria that like that heat. Okay, so here we go, fracture zones. And these are major lines of weaknesses in Earth's crust that cross the mid-ocean ridge. Remember, we've got this ridge, these plates that are separating along a sphere. Okay, and so think of trying to bend a piece of paper around a basketball and do that smoothly. It's not going to work, right? But if we cut lines in it that are perpendicular to the direction that we're going, I don't know if this is making sense, but then we can wrap that piece of paper around the ball. So basically you need to relieve that stress and that I can't do this without showing you. So hopefully that makes sense, but try to think of that piece of paper wrapping around a basketball, and that it's impossible to do that smoothly. And so hopefully that helps and you can kind of see that. If I've totally confused you, I apologize. And I think I'll go ahead and stop there and continue on the next one.